Hare Krishna and a very warm welcome to all my dear angels. Now in this video, I will show you some mysterious properties of the number 9 and how to make the table of any number ending with 9. Means the end digit, the unit digit of that number is 9. It can be 19, 29, 39, 49, 129, 169, any digit number, but the end digit, the unit digit of the number should be 9. So how the properties of table of a number are used for making the table of any number ending with 9, I will show in this video, and also some of the mysterious properties of this table. So to understand all that, I am sharing my screen with you. Come with me to my screen. Yes. So I think that yes, first of all, confirm to me that my screen is visible to all of you and that I am also audible to all of you. Now, to make the table of any number ending with 9, we have to first understand the table of 9. The table of 9 is one of the most mysterious table among all single digit numbers. Among all single digit numbers, the table of 9 is the most mysterious table. Now, why I'm saying so, because I will show you practically that what are the mysteries hidden in the table of 9. When you write 9 into 1, you can write, what you do when you write 9 to 1, 9 to 2, you first of all write 0, then keep on writing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you reverse the writing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Means from the top you start with 0, go with up to 9, and then you go up to, from the bottom you start with 0 and go up to 9, and your table is ready. Even if you forget the products, then you can easily write with this technique 0, 9, 18, 27. Now what is the mystery in this table? Now you see, when you add any products, when you add the digits of any product like 0, 9, 0 plus 9 is 9, 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9, 5 plus 4 is 9, 6 plus 3 is 9, 7 plus 2 is 9, 8 plus 1 is 9, and lastly, 9 plus 0 is also 9. So what does that mean? It means when you multiply any number, maybe 2-digit number, 3-digit number, any digit number by 9, then the sum of the products, then the sum of all the digits of the number should always be 9. I repeat, when you multiply any number by 9, it can be any digit number. When you multiply any number by 9, and when I add all the digits of the numbers, all the digits of the product, it is called SDS, single digital sum. When I add all the digits of the products to get a single digital sum, then it should be always 9. If it is not 9, it means your product is wrong. It means your product, some mistake you have done in your product, because it cannot be any other number other than 9. When you multiply any number by 9, the sum of all the digits of the product should always be 9. And the reverse of this is that the divisibility condition for any number by 9 is that the SDS of that number should be 9. The reverse of what I have told you earlier is that the divisibility condition for 9 is, you want to check whether the number divisible by 9 or not. Just find the SDS of that number. If the SDS, single digital sum of that number is 9, it means that number should be divisible by 9. If it is not 9, then the number is not divisible by 9. These two conclusions we can draw from this table. As I see that the sum is always 9. The sum is always 9. Now, one thing more I want to show you. You see the product here, 1, 2, 3, 4, 5, 6, 7, 8, 8. And just at the last digit of the product, you see 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10, 5 plus 5 is 10, 6 plus 4 is 10, 7 plus 3 is 10, 8 plus 2 is 10, 9 plus 1 is 10, and 10 plus 0 is 10, right? What does it mean? It means when I'm making a table of any number which ending with 9, that means my end digit should always be, the end digits should always be in this order: 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 9 is the only number in whose table all the digits from 9 to 1 are coming sequentially. There is no digit missing. You see, there is no digit missing. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All the digits from 9 to 0 are coming in a sequence. No digit missing. So 9 is the only number in which all the digits are coming sequentially. And if you write the table of any other number from which is ending with 9, say 29, 39, 49, the end digit will always be in the same manner: 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Because the sum of the multiplier and the last digit should always be equal to 10. Should always be equal to 10. Means this number, 9 is this number. They are both complement of each other. 1 plus 9 are complement each other for base 10. In the same way, 2 and 8. I am multiplying the number by 2. The last number should always be 8 because they are both complement of number 10. So the last number is always 98765432210. This is a very amazing property of number 9, and I will use this property to make the table of any number ending with 9. Now the third property, very amazing property of number table 9, is that you have to remember the table of 9 up to half, up to only half. Up to only half. Why I'm showing so? Because see, I have shaded all these color, all these numbers by some special colors. Now 9 into 5 is 45. 9 into 5 is 45. You just remember table up to 9 into 5, 45. Because after that, the table get reversed. The table get reversed. Because 9 into 6 is reverse of 45. That is 54. In the same way, 9 into 7, a reverse of 9 into 4 means 63. 9 into 8 is reverse of 9 into 3. That is reverse of 27. That is 72. In the same way, 9 into 9 is reverse of 9 into 18. 18 reverse is 81. And lastly, 9 into 10 is reverse of 9 into 01, and that is reverse of 09. That is equal to 090. In this way, what does this mean? That if I remember the table of 9 up to half only, I can rewrite the full table by reversing the number. Another very special feature is this shows. What does this show? That if I add 9 into 5 plus 9 into 6, then what do I get? 45 plus 54, that is 99. So 9 into 5 plus 9 into 6 is equal to 9. I take common. 5 plus 6 is 11. 9 into 11 is 99. In the same way, 9 into 4 plus 9 plus and 9 to 7. If I add both these numbers, I take 9 common, to 4 plus 7. 4 plus 7 is again 11. 11 into 9 is 99. In the same way, this is true for all these numbers. 9 into 8 plus 9 into 3. 9 into 9 plus 9 into 2. 9 into 10 plus 9 into 1. The sum is always 99. Now, what conclusion we can draw from this? The conclusion we can draw from this number, that when you add any two-digit numbers which are reverse of each other, here in the table it is a 27, 36, 45. But otherwise, even otherwise, if you add any two numbers which are reverse of each other, and you have to add those numbers. So what you do? Just add both the digits and multiply by 11. Suppose you have to add 32 plus 23. 32 plus 23. So what do you do? Add 3 plus 2. 3 plus 2 is 5. And 5 into 11 is 55. So your answer will be 55. So to add any two-digit numbers which are reverse of each other, just add both the digits and multiply by 11. In the same way, I am showing you the similar feature for subtraction. Now you see 9 into 3 is 27, and 9 into 3 is 27, and what is this? 9 into 8 is 72. When I subtract 27 from 72, what do I get? 9 into 8 minus 9 into 3. So I get 9 common. 8 minus 3 is 5. 8 minus 3 is 5. And 5 into 9 is 45. What does it mean? It means that when I have to subtract any two numbers which are reverse of each other, just subtract both the numbers and multiply by 9. You see here 9 into 3 is 27, 9 into 8 is 72. When I subtract 27 from 72, I subtract 7 minus 2, I get 5. And 5 into 9 is 45. And that is my answer. In the same way, I can take for this also. I can take for this 9 into 2 is 18. And when I subtract from 9 to 9, 81. Now 18 and 81 are reverse of each other. 18 and 81 are reverse of each other, and I have to find their difference. So just subtract 8 minus 1. 8 minus 1 is 7, and 7 minus 9 is 63. 7 minus 9 is 63. So that answer will get. So to subtract, I repeat, any two-digit numbers, which are reverse of each other, just subtract both the digits and multiply by 9. And in the same way, when you have to add any two-digit numbers which are reverse of each other, just add both the digits and multiply by 11. So these four conclusions we can draw from this table of 9, a very mysterious table, a wonderful table. And these two properties that I shown you, that the sum of the products, all the digits of the products to always be 9, and that the sum of the multiplier and the last digit of the product is equal to 10. I will use these concepts to make the table of any number which is ending with 9. Right? Now, suppose you have to make the table of 29, right? So 29 into 1 is 29. Now, what is 1 more than 2? What is in the table of 9? I have written 0. I have written 0, 9. Now, 1 more than 0 is 1. So I keep on adding 1 to the number. 1 plus 0 plus 1, 1 plus 1 is, you see, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. In this way, I'm getting the number. And the last number I show you is always this 98765432210. Now, in the same way, for the table of 29, for the table of 29. What is 1 more than 2? It is 3. So when I write, I first write 29, and then 2 plus 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. 17, 3 plus 20. 20 plus 3 is 23. 23 plus 3 is 26. And 26 plus 9 is 29. 26 plus 3 is 29. And the last number, of course, as I told you earlier, it will always be 9876543210. 9876543210. No number is missing. No number is missing. It is coming in a sequence, in this sequence only, with no number missing. Now, in the end, I'm getting 290. Now, here you see in this table, I'm getting the product as 29 into 10 as 290. Now, the same number I will get if I multiply 29 by 10, 290. Here I'm getting by addition, and by multiplication also I get the same number. It means my table is 100% correct. It is no mistake in making my table, because if I done any mistake anywhere, I will not get the number 29. In the end, I will not get the number 29. It can be 27, 28, maybe other number. I will not get the 29. If I'm getting the number 29 at the end, it means my table is 100% correct. There's no mistake in doing any addition or writing any number. So this is 100% correct table. In the same way, you can make table of any other number. Suppose you have to make the table of, the general formula is, if you have to make a table of A9, you have to make a table of A9, then keep on adding A plus 1 to the product, to all the previous products. Suppose you have to make a table of 59, then what is more than 5? Here is 5. So what is A plus 1? A plus 1 is 5 plus 1. That is 6. It means you keep on adding 6 to the every product. 59, then keep on adding 6 plus 5, 11, 11 plus 6, 17, 70 plus 6, 23, and keep on getting the numbers. And in the end, you will get answer as 59. 59 into 10 is 590. So your answer by addition also 590, by product also is, by production also is 590. Then it means your table is 100% correct. Of course, the last digit, as I told you already, it will always be 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It can't be any other number, and they will all come in the same sequence. It will all come in the, with no number missing, right? Now I'm showing that how to make a table of any number of series of 9. Suppose I have to make a table of 99. Now, first I showed you how to make a table of any number ending with 9. I'm showing you how to make a table of any number with series of 9, 99, 999, 49. Now 99 into 1 is 99. When I have to make a table of 99 into 2, what I do? 9 into 2 is 18. I know 9 into 2 is 18. So this one is extra. This 9 is extra. So what I do? I simply insert this 9 between 18. First I write 2 into 9 is 18. Then I simply insert this 9 in between these two numbers, and I get my answer as 198. 198. In the same way, 9 into 3. 9 into 3 is what? 9 into 3 is 27. And this 9 is extra. 19 is extra. I simply insert this 9 in between 2 and 7. I get the answer as 297. 297. You see, this 9 is the extra 9. This 9 is the extra 9, which is before the given 9. In the same way, for every number, you can write the table. And suppose I have to make a table of 999 or 49, then 49 into 6. Now 9 into 6 is 54. And these 3 9 are extra. So just put these 3 9 in between the product of single line and 6. I get the answer 59994. Suppose I have to multiply this series 5 9s into 8. Now this 4 9s are extra. 4 9s are extra. So what I do, I multiply 9 into 8. I get 72. And then I put these 4 extra between 7 and 2. I get the answer as 7, then 4 times 9, then 2. So these are very simple techniques. And you can use this technique to make the table of any number, any series of 9, any 99, 999, 49, 59, 69. Just multiply 19 by 6 and insert the additional 9s. Insert the additional lines between the digits of the product, between the digits of the single product of 9 and the given number. Right? Now, suppose I have to make a square. Now I'm showing you a very special property of square of number 9. 9 is a very mysterious number. And I'm showing you one more mysterious property is number 9. 9 square is equal to 81. I have to find the square of 99 square. Now this 9 is extra. The square is definitely 4 digits. So what I do, I first put 4 digits. I write 8 and 1, leaving a dash, leaving a gap between both the numbers. Now for writing the square, what I do, I write 1 less than 1. 1 less than 1 is 0. One number less than 1, it is 0. And 1 more than 8 is equal to 9. So answer is 9801. So for 1 extra 9, I have put 1 9 extra and 1 0 extra. For 1 9 extra, I have put 1 9 and 1 0 extra. In the same way, when I have to find the square of 999, 4 series of 9, I mean double nine square. Now 3 9s are extra. 3 9s are extra. So what will I do? I will first write 3 9s. I will first write 3 9s. Then I will write 1 8. Then I will write 30 in that one. Means 9 into 9 is 81. I simply write that. Then between these three 9, I put 3 zeros, and before this 8, I put 3 nines. Just you can see from this, for one extra 9, I put one extra 9 before 8, 1 0 between 8 and 1. In the same way, 3 0 between 8 and 1, and 3 nines before 8. And this way you can make that square of any number. Like it is now how many digits? 6 times 9, series of 6 times of 9. I have to find the square. So 9 into 9 is 81. I write 81, and these additional 9s are 5. Additional 9s are 5. So I put 5 zeros between 8 and 1, and I write 5 nines before 81, and I get the answer. So 9 shows a very mysterious property of finding the squares of the number. And in the same way, this property also applies to the number 3 and 6 that I have already shown you in some other video, how to find the squares of repeating series of 9, 3, and 6. But for the time being, I have shown you for 9. So I have shown you how to make the table of any number ending with 9, and 4 mysterious properties of table of 9, and also how to make the table of any number of repeating series of 9, say 99, 999, 49, how to make the table in just fraction of a second without doing any multiplication. You are not doing any multiplication. In the same way, when I am making a table of any number ending with 9, you are not doing any multiplication. You are just using the concept of, this is totally based on the concept of vernacular numbers. Means what is one more than the given number. That is called, and means I am using, for writing this last number, I am using the concept of vernacular number, and for writing the this number before the last number, I am using the concept of one more than the previous one. That is another sutra of speed mental math, ekadikena purvena. But let us learn it a simple way. You have to just add one more than the previous one. 29 means 2 plus 1. Suppose you have to make the table of 69. Means keep on adding 6 plus 1, 7, 7, 7, 7 to every previous product. In the same way, for making a table of 129 means A is here 12. So 12 plus 1, 13. 13, keep on adding 13, 13, 13, 13 to every previous number, every previous product. And of course, the last number will always be 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So I have shown you everything about how to add and multiply, add and subtract two numbers which are reverse of each other by the table of 9. And also that table of 9 is to subtract it only half, because after half the table get reversed. And how to find whether any given number is divisible by 9 or not. That I have showed you in this table by means of this table, right? So I hope that this is really a wonderful video for you, and you must have learned something unique which you have not earlier. So I stop now sharing my video. Yes, students. So I hope that this video has really been very precious for you, very wonderful for you, and that it is really worth your precious time. And if you really feel that it's added to your knowledge, to your information, you have found it valuable, worth your time, then do subscribe to my channel, SSKG, and also share this video among your friends. Share this video among your friends. And if you want to learn such magical techniques, if you want to learn, like you want to become a mathematician, I call it mathematician. If you want to learn many more magical games, then do subscribe to my channel and do call me at my number 9265418811. 9265418811. I will teach you. I will give you all the details of my course, and then you can learn all the techniques of speed mental math. So thank you very much for sharing your valuable time, your precious time with me, for sharing your time for watching my video. And I wish you all best of luck. So thank you very much. Have a great day. Have a nice day. Have a wonderful day. Hare Krishna.